Alright, so this video is going to be focusing on recursive formulas, both of arithmetic sequences and geometric sequences. Now there's one difference between these two different types of sequences. Notice the arithmetic sequence, we always look at the previous term. So we have a sub n is equal to the previous term, which is said a sub n minus 1, plus the d, which is a common difference. Okay, so all we're doing with arithmetic sequences is adding. We add a number to some number to get the next. So the previous number plus the common difference gives me the next. Geometric sequence is talking about multiplication. So to get any term, we look at the previous term and we multiply it by r. Now, I just noticed something. I'm forgetting something. Whenever using a recursive formula, you must have an initial condition. So that is the a sub 1. So you must be given that first term to start with. Otherwise, you have nowhere to start. Okay? So now, let's look at a couple of sequences that are arithmetic and geometric, and let's see how to come up with the recursive formulas of these. So if I have -8, -2, 4, and 10, I want to come up with a recursive formula for this sequence. So I first need to find out, is this arithmetic or is it geometric? Well, if we look at this, from -8 to -2, I'm adding 6. From -2 to 4, again, I'm going to add 6. And then from 4 to 10, I add 6 again. Alright? So if we're adding the same number to get the next term in the sequence, always, this is arithmetic, because you add that common difference. So we know that our d is plus 6. So let's write down the formula for the arithmetic sequence, the recursive formula. So plus the common difference. Now, this is a unit that's heavy in formulas. If you write down the formula, what you're using, it will always make the problem that much easier. So, to find a sub n, we look at the previous term, a sub n minus 1, and add the common difference, which in this case is 6. Now remember, with recursive formulas, you need your initial condition. So a sub 1 is -8. That's just your first term of the sequence, which is given to us right there. So now let's try to find we have 1, 2, 3, 4. Let's try to find the fifth and sixth term. So a sub 5 would be the previous term, so a sub 4 plus 6. Now, we know that a sub 4 up here is 10. So if we plug a 10 in for that, 10 plus 6, 16. It's that simple. To find a sub 6, we look at the previous term, which is 16, add 6 more to it, and we get 22. So this is a very easy way or method to find the next term in the sequence. Okay? So let's look at another sequence. Let's say we have 1.2, 7.2, 43.2, 259.2. Now, if you look at this, it should be fairly easy to see that it's not arithmetic. From 1.2 to 7.2, you would add 6. Okay? But then from 7.2 to 43.2, we would add 36. So right then and there, these are not the same. We know this is not arithmetic. Okay? So it probably is going to be geometric. Now the way that we could test this and make sure that it is if we take the second term and divide it by the first, so 7.2 over 1.2, we should get a ratio that is common throughout the sequence. So we go down the line. So 43.2 divided by its previous term, which now is 7.2, should equal 259.2 divided by its previous term, 43.2. So do this in your calculators. 7.2 over 1.2. Well, you'll get 6. 43.2 divided by 7.2. Again, you'll get 6. This divided by that, so 259.2 divided by 43.2, we'll get 6 again. And if that is the case for all of our ratios, we have a common ratio of 6, and that means that this is geometric. So now we can write our recursive formula. The previous term times the common ratio, right? Okay, so now let's plug in that 6 for r. And now let's try to find the fifth and sixth terms. Again, it's just as easy as arithmetic sequences. So the fifth term, I'm forgetting one thing. My initial condition. You need to write the initial condition. Sorry about that, but there it is. Okay, so there's my initial condition with the arithmetic formula. Now to find the fifth term, I look at the fourth term. So we have 1, 2, 3, 4. The fourth term is 259.2. And I multiply it by the common ratio, which is 6. So now 259.2 times 6 gives me 1,555.2. Now the good thing about this the recursive formula is if you're doing this in the calculator, you don't really have to type this number back in because it's already stored as the answer. So now to get the next term, we take whatever a sub 5 is, which is this 1,555.2, and we multiply it by 6. So all I have to do in the calculator is times 6. You should get a and s times 6, and that should give you a number of 9,331.2. And there's the recursive formula worked out for you. It's very simple, and it's an easy way to get the next few terms. Alright, thanks for watching.